All right. Pythagorean theorem. The Pythagorean theorem only works for right triangles. So you have to have a right angle in here. What's the side opposite the right angle called? The other two sides are called? So it doesn't matter which is A or which is B, but the hypotenuse is always C. So then, C squared equals A squared plus B squared. C squared equals A squared plus B squared. Okay. Do not write it as A squared plus B squared equals C squared, because when we get to the figuring out whether it's an obtuse or an acute triangle, we want it in this order. Okay. All right. So let's say we have a triangle here that this is 24 and this is 10. How long is C here? Well, how would we set it up? C squared equals 24 squared plus 10 squared. C squared. Get out your calculators. 24 squared. Is that like 576? 10 squared. So C squared equals 676. Take the square root of each side. C equals 26. How do we find side B over here? C squared equals A squared plus B squared, right? What's C? 15 squared equals 12 squared plus B squared. What's 15 squared? 225. 12 squared? Subtract. $81, right? Yeah. Take the square root. B is 9. Easy peasy lemon squeezy, right? But not all triangles work out to be nice whole numbers. What's X? Is X C, A, or B? C in this case, because it's opposite the right angle. What's 27 squared? 729. Add them together. $850, right? What's the square root of 850? What? 29.15. Sounds good to me. Okay. Now, that's if they allow you to do that. What if they say in the direction that it has to be in simplest radical form? We have to break down the square root of 850. What's the biggest perfect square? It goes into 850 evenly. Well, 100 doesn't go in there. 81 probably doesn't go in there. 64 probably does not. 49, no. 36, no. 25? How many times does 25 go into 850? 30? 30? 34. Any perfect squares go into 34? No. So it would be 5 square root of 34 would be simplest radical form. So if it asks for a decimal, that's what it is. If it asks for simplest radical form, that's what that is. Let's do another one, simplest radical form. This is 20. This is 5. What is X here? How do I set it up? 20 squared is 400. 5 squared is? We subtract 25. 375 equals a squared. What's the biggest square goes in 375? Probably 25 again. How many times does 25 go into it? 15. Any perfect squares go into 15? Nope. So 5 square root of 15 is your answer. Okay? So that's perfect squares. Okay? Simplest radical form. Then we have the converse to the Pythagorean theorem. So c squared could be less than a squared plus b squared. C squared could be equal to a squared plus b squared. Or c squared could be greater than a squared plus b squared. If it's less than a squared plus b squared, it's a good looking triangle. So what kind of a triangle is a good looking triangle? An acute triangle. Yeah, it is really an acute triangle. Thank you for laughing. All right. Equal to is right triangle. Greater than would be then obtuse. So let's say you had a triangle. That's 16 and 34 and 42. Acute, obtuse, or right? Well, 42 is the biggest one, so we set 42 squared equal to 16 squared plus 34 squared. What's 42 squared?
1,764.
16 squared. 34 squared.
1,156.
What? So this is what, 1412?
Yeah.
So it's greater than? So this would be? All right. Twelve square root of 18 and 20. 12 square root of 18 and 20. Well, what's your longest side there? 20. So 20 squared compared to 12 squared plus the square root of 18 squared. 20 squared is 400. Twelve squared is? What's the square root of 18 squared? 18. When you square a square root, you get what's underneath it. Okay? So when you square a square root, you get what's underneath. This one is obviously obtuse. Okay? All right. So, yeah.